Hello friends, in this video we will learn how to apply simplex method for a linear programming problem in order to find out the values of x1, x2, x3 and z. Before we start learning more about simplex method, let us first try to understand what is the need of simplex method and why did we introduce such a method. In the previous video, we have made use of graphical method to find out a solution for a given linear programming problem. The reason why we have to come across simplex method and avoid graphical method in some situation is because graphical method has got certain drawbacks. What are the drawbacks? Let us look at that. In graphical method, we make use of these subjects to constraint inequalities. We convert these into equations. We find out the coordinates and try to draw that particular equation as a line in graph. We plot all the equations in terms of line in the graph, and with help of these subject to constraints, we would identify the feasible region. With help of that, we would be successfully finding out x1 and x2 values. But what in case if we come across an extra variable x3? Graphical method always deals with linear programming problem where the subject to constraint inequalities has got only two variables. If in case a subject to constraint inequalities come across more than two variables, then graphical method would not be suitable. Why? Because the variable x1 would be acting as one end of the line and variable x2 would be acting as the second end of the same line in the graphical method. On introduction of the third variable, we would not be able to plot it as a line. We all know that in general, a line has got only two ends. Since x1 acted as one end, x2 would act as the other end of the same line, and we would not be able to plot the third variable. This was the only drawback of graphical method. If in case a subject to constraint for a given LPP comes up with more number of variables, more than two variables, then it was very difficult for us to apply graphical method. To overcome such a drawback, we have come across a method called simplex method for LPP. We can make use of this method and solve the given LPP for any number of variables in the subject to inequalities. You can have any number of variables in the simplex method in the subject to constraint in order to apply the simplex method. Since we have understood the need for simplex method, let us go ahead. Before even we start solving simplex method, let us first learn what are the new variables we will be making use of in simplex method. In simplex method, we will be introducing new variables like slack variables, surplus variable and artificial variable. But for simplex method, we will only make use of slack variable. So let us only try to understand what do we mean by slack variable. Slack variable is a variable. It's a positive value that is added to the LHS part of the subject to constraint in order to convert this whole inequalities into an equation. In graphical method, we converted these inequalities into equations directly. We did not make use of any method. We directly removed this less than equals to symbol and replaced this by equals to sign so that we could convert this into an equation. But here we have one method that we have to follow in order to convert these inequalities into an equation, and that is by adding a slack variable, which is a positive variable which we add onto the LHS part of the subject to constraint in order to convert these whole inequalities into an equation. Now in simplex method, we only make use of slack variables, and slack variables are only used in a situation where the subject to constraint has got LHS less than equals to RHS. Only if in case the subject to constraint has got inequalities where LHS is less than equals to RHS, only then we make use of slack variables. Since the given problem has got all the subject to constraint inequalities where all the inequalities have got LHS is less than equals to RHS, and most of the problems in simplex method follow the same structure. They only come up with such a condition where the LHS part of the subject to constraint is always less than equals to RHS. So let us try to solve this. Before we solve, try to check for this function, objective function. The objective function is always supposed to be a maximization function, but by default we got it as minimization function. So we have to first convert this into a maximization function and then proceed further. Let us try doing it. Converting the minimization function into maximization. Minimum of z is equals to maximum of z complement. When we convert a minimization function of z into a maximization function, it gets to be complemented. With this, we also come to a conclusion that all the RHS part, all the values in the RHS part will also be complemented only in terms of signs. So, max of z complement is equals to minus x1 plus 3 x2 minus 2 x3. So this is my maximization function. Initially it was given as a minimization function. I converted that into maximization, and after conversion we obtained it as maximization of z complement. And once it has been complemented, even the RHS part also will be getting complemented only in terms of arithmetic signs. Now, subject to constraints. For each of these inequalities, we will only add the slack variables. 3 x1 minus x2 plus 3 x3 plus s1 is equals to 7. Minus 2 x1 plus 4 x2. There is no x3, so proceed with only slack variable, that will be s2 and 12. The third inequality, 4x1 plus 3x2 plus 8x3 plus s3 is equals to 10. After introducing all the slack variables in the subject to constraint, we should also bring them down into the objective function. We know that all the variables which are present in subject to constraint should also be present in maximization function, in the objective function, in order to proceed further. Now this will be brought down to the maximization function as they are in terms of even arithmetic symbols. But since it is a complemented z, we know that we will have to even change the sign of these. So this will be 0 s1 minus 0 s2 minus 0 s3. The values for all the slack variables in the subject to constraint will be 1. S1 will have a value of 1, S2 will have a value of 1, and S3 will also have a value of 1. But the same slack variables, when they are brought down to the objective function, their values will be turned out to be 0. And that is why we have them marked as 0 S1 minus 0 S2 and minus 0 S3. Now make use of all these values and form a table to proceed further in order to apply Gauss-Jordan method. The values of the basic and non-basic variables in the objective function for the z complement row. The value of x1 was 1, value of x2 was minus 3, value of x3 is 2, s1 was 0, s2 was 0, s3 is 0, and there is no solution here and ratio is just left apart. Then comes down the value for all the subject to inequalities which has got only a slack variables. Consider the subject to constraint that has got only a slack variable s1 and find out the values of all the other variables amongst that equation. And in s1, x1 was 3, x2 is minus 1, x3 is 3, there is one s1, no s2, no s3, and the RHS will be 7. Similarly, S2, the subject to constraint inequalities which had this slack variable S2 and all the values of the basic and non-basic variables from that subject to constraint, which had x1 value of minus 2, x2 value of 4, x3 value was not there. There was no x3 present in the second subject to constraint, and then there is no S1, 1 S2, no S3, and the RHS part will be 12. Now S3, the x1 value in the third subject to constraint which had a slack variable S3 had -4, x2 had 3, x3 had a value 8. There will be no s1, no s2 and only s3, and RHS part would be 10. This is how we plot all the values of all the subjective constraint, inequalities and the objective function variables into a table. With help of this first row, which is also called as an index row, identify the entering variable. How do we identify the entering variable? First check for all the values in the index row, which is nothing but the z row. These are nothing but the values of the maximization function, the objective functions. With this, we come across that -3 is the leastest value. You'll have to find out for the leastest value amongst this index row. And the least value here for this row is -3. So, x2 will be your entering variable. And this plays a very important role. Now, x2 will be your entering variable. Since we have identified the entering variable, since we have identified -3 to be the entering variable, now this whole column will act as pivot column. With help of this pivot column, we should also find out the leaving variable. We should also find out the pivot row. Take all the values of this pivot column and divide them with the solution part. This will obviously be 0 since it is. And one more thing, we will never have to consider the values which have got negative signs. This values coming up with negative signs will not be considered for identifying the pivot row. Since it is negative, let me make it to be negative. Let me mention negative. And even S1 has got my negative sign, so let me mention it to be negative. And for this, 12 divided by 4, the answer would be 3. And the last row, 3 divided by 10, the answer would be 3.3. Amongst these, find out the least value. The least value amongst this would be 3 for me. So this row will act as a pivot row. And for the entering variable x2, s2 will be the leaving variable. In the steps further, this s2 will be replaced by x2. We will be taking out the value s2 and we will be replacing this s2 by x2 here. Let us start doing it. The first step is replace s2 by x2. Now we will have to, this is the leaving variable and this is the pivot row. Replace s2 by x2. There is a simple formula which we have to make use of in order to identify the new values for new x2 row. That is very simple. New x2 row is equals to current s2 row whole divided by the value for pivot column, value in the pivot column for that particular row, and the value of the pivot column in this particular row is 4. So the whole row divided by 4. Substitute the value this way. Take out all the values of the s2 row. -2, 4, -2, 4, 0, 0, 1, 0, 12, and we will not make use of this value of ratio in the calculations. Now find out the answer. 1 divided by 4 multiplied by -2. The answer will be -1 by 2. 1 divided by 4 multiplied by 4, the answer would be 1. Anything multiplied by 0 is 0. Anything multiplied by 0 is 0. And 1 divided by 4 multiplied by 1 will be 1 divided by 4. Anything multiplied by 1 will be the same number. And anything multiplied by 0 will be a 0. And this 1 divided by 4 multiplied by 12 will come up with 3. So these are the values of new x2 row. And be careful when you are trying to identify the values of the new x2 row. You have to carefully identify the pivot column, the pivot row, and along with that you should also pay good attention in order to identify the new values of the new row, new replaced row. These play a very vital role further in solving the problem. Now with this we came up with the value for new x2 row. Similarly, we'll have to find out the new values for all these other three existing rows. The value of new z row. New z complement row is equals to current z complement row minus of the value of pivot column for that particular row. The value of pivot column for this particular row is minus 3. Hence 3. It's minus 3 multiplied by new x2 row. This is the formula we have to make use of in order to find out the values for the new z complement row. Now bring down the values of all the z complemented rows. It is 1 minus 3, 2, 0, 0, 0 and a 0 even from the solution will have to be brought down here. Minus of minus 3 multiplied by all the values in the new x2 row. All the values in the new x2 row are minus 1 by 2, 1, 0, 0, 1 by 4, 0 and 3. And the answer for all these will be minus 1 by 2, 0, 2, 0, 3 divided by 4, 0 and 9. So these are the values of your new z complement row. Similarly, find out the values for new S1 row and S3 row. We also have a formula to find out the values of new S1 row. New S1 row is equals to current S1 row minus of the value of pivot column for that particular row. The value of pivot column for S1 row is minus 1. So it is minus of minus 1 multiplied by new x2 row. What are the values of S1 row? I have 3, minus 1, 3, 1, 0, 0, 7, minus of minus 1 multiplied by, or else you can just draw a bracket here and write the values of new x2 row. It is minus 1 by 2, 1, 0, 0, 1 by 4, 0 and 3. And the values for your new S1 row will be 5 by 2, 0, 3, 1, 1 divided by 4, 0 and 10. After solving this, I will come up with these answer, and these are nothing but your new values for the new S1 row. Now for new S3 row. The same formula, current S3 row minus of its pivot column value. The pivot column value for the S3 row. The pivot column value for S3 row will be 3 plus 3. So this will be minus 3 multiplied by new x2 row. And the values of S3 row are minus 4, 3, 8, 0, 0, 1, 10, minus of 3 multiplied by values of new x2 row, minus 1 by 2, 1, 0, 0, 1 divided by 4, 0 and 3. And the answer for this will be minus 5 by 2, 0, 8, 0, minus 3 by 4, 1 and 1. So these are the values of new S3 row. The all new values which we have found for the existing Z complement S1, S3 and also the X2 row will act as the values for the new table in the second iteration. This is the first iteration. Now plot all the values that we have found in the first iteration, the new values that we have found for Z row, S1 row, and we have identified new X2 row and S3 row. Plot all the new values of all these into the new table. The values of new Z complement row is minus 1 by 2 for X1, 0 for X2, 2 for X3, 0 for S1, 3 divided by 4 for S2 and 0 for S3. Solution was 9. And the values of new S1 row at the end of the first iteration was 5 by 2 for X1, 0 for X2, 3 for X3, 1 for S1, 1 divided by 4 for S2 and 0 for S3, and then solution was 10. Values of new X2 row minus 1 by 2, 1, 0, 0, 1 by 4, 0 and 3. The values of new X3 row minus 5 divided by 2, 0, 8, 0, minus 3 divided by 4, 1 and 1. So this is your new table, and the values we have obtained at the end of the first iteration will be the values in the new table for the second iterations. This is a second iteration. In the second iteration, again follow the same step. These steps, whatever we follow, the steps we use to identify the entering row, the leaving row, all these fall under Gauss-Jordan method. We make use of Gauss-Jordan method in order to identify the leaving variable, entry variable, and with help of that we will also find out the values, new values for all the existing rows. And the method that helps us to find out all these things is nothing but Gauss-Jordan method. Now apply the same Gauss-Jordan method that we applied in the first iteration. Now consider the index row, which is nothing but the objective function rows for this particular table. Consider the leastest value amongst this row. The least value amongst this row is minus 1 by 2. So for the second iteration, x1 will be the leaving variable, and this is called as pivot column. With help of this pivot column, identify the pivot row. Similarly, try to divide all the values of this pivot column from the solution part and find out the ratio. This part I will not be able to find out, it is negative, and I will never make use of the ratio which comes up for the index row. We will never make use of this row. Even in case if I come across with the leastest value amongst this whole column here in this row, then we will never make use of this. Since it is a objective function, we will never consider this row. So all the other rows apart from the Z row. 10 divided by 5 divided by 2. The answer will be 4, and this is again negative. As I have already told that we will never make use of the values which come up with negative symbol. Since these both are coming up with negative symbols, we will never consider them. We will never take a pain of even solving them. With this, we come to a conclusion that this row is a pivot row. So S1 will be the leaving row, and this is called as pivot row. Apply the same method what we applied in the iteration number 1. Now we have to write a simple statement. Replace S1 by X1. Now what is the formula to find out the values of X1 row? New X1 row is equals to current S1 row whole divided by the pivot column value for that row. The pivot column value for this row is 5 divided by 2. Now try to, since it is division, I'll just put it upside down and try to multiply with all the values of S1 row. 5 divided by 2, 0, 3, 1, 1 divided by 4, 0, 10. And the values of new X1 row will be 1, 0, 6 divided by 5, 2 divided by 5, 1 divided by 10, 0 and 4. These are the values of new X1 row. With help of this new X1 row, we will try to find out the values, new values for all these other existing rows like Z complement row, X2 row and S3 row. The formulas still remain the same. New Z complement row is equals to current Z complement row minus the pivot column value for that particular row. The pivot column value for this row is minus 1 by 2 multiplied by new X1 row. Bring down the values of the old Z row or current Z row. 1 minus 1 by 2, 0, 2, 0, 3 divided by 4, 0 and 9. This will be minus of minus 1 divided by 2 multiplied by, or you can just even exclude the star symbol and write down the values of new X1 row. This is the values of the new X1 row. 1, 0, 6 divided by 5, 2 divided by 5, 1 divided by 10, 0 and 4. So these are the values of your new X2 row. Now with this we come across the values of new Z row. It will be 0, 0, 13 divided by 5, 1 divided by 5, 4 divided by 5, 0 and 11. Now these are the values of your new Z complement row. Similarly, find out the values for new X2 row. New X2 row is equals to current X2 row minus of the pivot column value for that row. The pivot column value for this row is minus 1 by 2. Minus 1 by 2 multiplied by new X1 row. Bring down the values of the X2 row. Current X2 row, it's minus 1 by 2. Minus 1 divided by 2, 1, 0, 0, 1 divided by 4, 0, 3. Minus of minus 1 divided by 2 and the values of new X1 row. 1, 0, 6 divided by 5, 2 divided by 5, 1 divided by 10, 0 and 4. Now the values of new X2 row will be 0, 1, 3 divided by 5, 1 divided by 5, 3 divided by 10, 0 and 5. These are the values of your new X2 row. Now Find out the values for new x3 row. New S3 row. New S3 row is equals to current S3 row minus of the pivot column value for that row. The pivot column value for this row is minus 5 divided by 2. That is minus 5 divided by 2 multiplied by new x2, sorry, this is x1 row. Bring down the values of S3 row. The values of S3 row are minus 5 divided by 2, 0, 8, 0, minus 3 divided by 4, 1, and one more 1. Minus of minus 5 divided by 2 and values of new x1 row. Values of new x1 row are 1, 0, 6 divided by 5, 2 divided by 5, 1 divided by 10, 0 and 4. So the answer for the new S3 row will be 0, 0, 13 divided by 5, 1 divided by 5, 4 divided by 5, 0 and 11. So these are the values of your new S3 row. So with this we end up the second iteration. At the end of the second iteration, plot all these values of all these new values for the existing rows into a table and check if this has reached the solution. Now this is the table for the end of the second iteration. Plot all the values of the new z complement row. The values of this new z complement row is 0, 0, 13 by 5, 0, 0, 13 by 5, 1 by 5, 4 divided by 5, 0 and 11. And the values of new x1 row. New x1 row will be this 1, 0, 6 divided by 5, 2 divided by 5, 1, 0, 6 divided by 5, 2 divided by 5, 1 by 10, 0 and 4. Now values of new x2 row. Values of new x2 row is 0, 1, 3 divided by 5, 1 divided by 5, 3 divided by 10, 0 and 5. Values of new S3 row 0, 0, 13 by 5, 1 divided by 5, 4 divided by 5, 0 and 11. Now check for the values in the index row. We will have to find out if there is any negative value here in the index row. At the end of the second iteration, we find that there are no negative values in the index row. So this condition indicates that the problem has reached the solution. We have obtained the optimum solution here, and we can also confirm that the solution for this given problem is optimum. And the reason for this is at the end of the second iteration we come across a situation wherein there are no negative values in the index row, which is nothing but the objective function row. So this indicates that there are values for x, so this indicates that the value for x1 will be 4 and value for x2 will be 5. Since we have not brought down the value x3 here, we can assume that to be 0. So the value of x1 will be 4, value of x2 will be 5 and value of x3 will be 0. Now try to substitute these values of x1, x2, x3 into the z function. Our z function was max of z complement. I come across something like minus x1 plus 3 x2 minus 2 x3. Substitute these values for the z function. x1 is 4 minus 4 plus x2 is 5. 3 multiplied by 5 minus x3 is 0. 2 multiplied by 0. So this will lead to an answer 11. So with this we also conclude that the value of z is equals to 11. This is how we apply simplex method for linear programming problem in order to find the optimum solution. We introduce the slack variables and make use of only slack variables, and we find out the values for x1, x2 and x3 and also z simultaneously. Thank you.